Hello. Today we're just going to be messing around with constraints. I figured they might be very handy for creating a character and understanding how it moves. So let's just go through all the transform constraints. Let's go through all the transform constraints. So let's make a couple cubes. Actually, we'll do just 2 cubes each for each one. And each one will be different constraints. The bottom one will have our constraints. So let's do a copy location constraint. And quite all it does, moves it to that location. Okay, is that all it does? What if I decrease if I decrease its influence and move it around? Interesting. So even if I can... So constraining its location and changing the influence means it'll always move towards an object or wherever you decide to constrain it. Let's see, what else do we have? We have copy rotation. Very simple, probably. So I drop our data block to this cube, nothing should change. But if I rotate this, their rotation is synced. And if I change the influence, I assume it just won't rotate as much. So this would be good for gear trains. But what's interesting is 0.3 influence and 1 influence. It looks like they're basically the same. Would that work? But this would be good for like gear trains, for example. If I rotate, what if I do them to each other? Let me see if I can do that. If I copy rotation to that one, but then to change the influence. That might be buggy. I don't think that's a good idea. But if I rotate this one, let's change the influence to 1. I rotate this one, and then duplicate this one down. However, this one will target this one. Then if I decrease the influence, and if I rotate this one, not so much. They just rotate together. So I guess it just makes... Yeah, they just rotate together. What's next? We have copy scale. Also simple, I assume. Sync the scale. Can I change the scale of this one? No. When I add a constraint, I can't manipulate this other one. And in order to manipulate this other one, I have to change this one. What about constraint settings? Influence, it just won't scale as much, which makes sense. So just the ratio between the two. Target world space. I'm not going to worry about that for now. What about power? Okay, power is also very, very similar, it looks like. But what is the difference between power and influence? I think power just... Yes, power you can infinitely scale, it looks like. Influence, however, you can only do 1 or 0. So influence is a ratio. Power is a limit, I would describe it as. All right. We should add 2 more cubes. Let's add a couple more. Now add a constraint. Copy transformations. All right. Will this apply? Oh. Interesting. So this will just help it move it in a in the same direction. When you move one, they'll all move. So does that mean if, let's say I make, I link a ton of these, right? And I make a train. So now if I change the influence, but if we change the influence too high, it'll go right to it. So I want them to move together at the same rate. That would probably be a copy location restraint then. Will it? Okay, so transformation is straight up just essentially the last three we did combined. What about this one? Limit distance. So this is the one I experimented with earlier. So if I limit the distance here, it will lock it and keep it around that axis, which is very good. I think I should use constraints more because constraints make things more interesting, makes things more real, and it'll be good for like making mechanics or mechanical animations, which would be nice. Also improve character setting a bit so things don't get too out of hand. And then influence, how much does it let it? That's interesting. So if I change the influence to not 1, I can straight up just pull it. The influence, I assume operation still applies. Then we could do this and make it real close. But I assume it would also work this way? Yes. So it allows us to do essentially rotation in all directions. Or what about scale? Would scale affect it? No, scale would not affect it. Limit location. Oh. That's new. That's okay. We have minimum X, minimum Y. So now if can we take its current location? I wonder if there's a way where we could take its current location and set those as values. So if I did those, whoops, could I do that? If I shift, copy, nope, it's like that's not going to work. I could like take its current, oh, another thing, hold on, maximum Z. Now I shouldn't be, okay. So minimum obviously prevents it from going one way. Maximum means it can't go to that. So now it can go infinitely below, but its origin. And all constraints apply to the origin. And when Y is 0, now I can only move it backwards. Okay, so we don't need that second cube for that one. What else do we have? We have limit rotation. I assume it's the same thing. Yep, set a maximum and a minimum. And it will only, this will be good for like creating rigs for human joints or rigging hair. If I constrain that, I'll cross the Z. I can't, although it says I am rotating it, it won't go any more than 90 degrees. That one's very simple. So I assume I like constraints so far. I like modifiers. Modifiers are nice. They create non-destructive workflows. So do constraints. Physics are fun because physics do cool animations and stuff. Right, and then, oops. Constraint, limit scale. Oh, I just saw one of the future ones. That one looks very good. Limit scale, very simple. It won't let me scale it past a certain point. So if I say, hey, I'm not sure how big I want, let's say I have this wall, right? Right? I know I want the wall to be, I know I want the wall to be this thick, but I'm not sure how large I want it to be, like wide. What I can do is limit the maximum to however thick I want it to be. All right, so I want it that thick. And now when I scale it, it'll stick to those two axes, and we'll change shape and will not scale it. But if I remove that, it'll return back to its original form. So what's the point of doing that, I suppose, rather than just not having that? And I guess it's just non-destructive. You can change this at any time, I suppose. That's interesting. My browser on. All right. Next up, we have the maintain volume. I think this would be good. So this has a volume of, it looks like 1. Okay, so now, this will be very, very useful for 3D animation. You see, in 3D animation, one of the principles is when you, let's say I'm moving an object and it bounces off, it goes whoosh, it goes, and then it squishes down, and then it pops back up. Well, a very important to maintain the somewhat realism of animation is to ensure that it has the same volume as it did. So it doesn't, you can exaggerate, but I guess exaggerate with the same volume. Yes, you can break those rules if you want to, but depending on what you're going for, you'll want to maintain the volume. So this will be very good for animation. And if you want a little bit, you could go here, a little bit of variation, but overall, very, very handy. Now I think we have 1 or 2 more. Got transformation. Okay. Interesting. Looks like we do need a second object. Duplicate that. Target this one. All right. What happens when I move this? Nothing. Why don't I move this? Nothing. When I press play, nothing. Looks like there's a map to, okay, and a map from. Map from and a map to. So if let's say I change the X minimum to that, and I change the X max to that, what happens if I, nope, what happens if I do this? What if I press play? Interesting. I don't know. Use one transform property from target to control another or the same on the property owner. I'm not sure. Oh, why is there 2? Maybe that's why? No. What about map 2? Source axis. Oh, that did something. I'm not sure. Well, I guess we'll have to explore that another day. Now for the last one. Constraints. Transform cache. That has something to do with a file. I wouldn't know what to do. Yeah, no, I wouldn't know what to do for that. So we got 2 mystery ones that we're not quite sure what they do. I'm gonna see, maybe I'm gonna see if there's one more that I like that maybe I know I could do right now. Track 2. Apply constraint, follow path. I know what that does. Geometry attribute pivot, shrink wrap. We did track 2. And tracked to you. Across. Okay. That's good. So it looks like it's facing that object. If I move it. Oh, okay. This will be very useful for a character I'm making. You see, this character has floating parts, but the floating parts won't always face each other. This constraint will allow me to make sure that no matter where I go, it will face. Now, if I add a second constraint and I do limit distance, and let's say I go to this object again and decrease that, now, no matter where I move this, it will stay that same distance, and it will always will stay that same distance and it will always face that. Though I wonder if there's a way to make it move a little bit easier. Maybe if I move it further away. It feels kind of difficult to move right now. But then if I remove this, will this just go flying? Yes, yes it will. Okay, so that is another thing of constraints. If you do this, even though it's constrained to that, it's still trying to move this up the z-axis. What that was, 60? But now if I remove this, it's going to apply all those. So I think that's all for constraints. Very handy, very handy. I'll have to use these in my next projects. I want to do projects that will essentially work on all skills at once, and I guess we're just exploring right now, and I guess I'm still figuring out what to make, which is a problem. I got more ideas though, which is good. I need to learn to have an idea, to execute it, and to do the idea for the idea instead of being like, oh, it's a bad idea. No, we must make. All right. See you tomorrow.